When an electrical arc jumps across an empty gap like this, it releases a sudden burst of intense power. But before that trigger is pulled, where exactly does all that energy live? Take a look at this schematic. We have two perfectly neutral parallel metal plates. Right now, there is no charge, no tension, and a disconnected battery. When we connect the battery, it begins pulling electrons from one plate and depositing them on the other. This forces a positive charge onto an increasingly positive plate. Because like charges repel, every new charge faces a growing repulsion pushing back against it. Overcoming that natural electrostatic repulsion is difficult. The battery has to exert immense external electrical work to cram those charges together against their will. In physics, that required physical work does not disappear. It transforms directly into stored electrostatic potential energy. The real question is how we measure it and where it hides. To calculate total energy, we start with a tiny fraction of work, dW, needed to move a minuscule charge, dQ, against an existing voltage, V. Voltage is the ratio of total charge to capacitance, so we replace V with Q over C. To find the total effort, we integrate. We sum up those tiny amounts of work, starting from zero charge up to the final total charge, Q. The math resolves cleanly. The total stored energy, U, equals Q squared over 2C. You might notice the fraction of 1/2 hiding in there. That exists purely because voltage grows from 0 up to V during the charging process. The average charging voltage is V over 2. This gives us two other perfectly equal ways to calculate energy, 1/2 CV squared and 1/2 QV. Looking at the dense arrays of metal in these variable air gap capacitors, it's natural to assume all the energy we calculated sits physically on the solid plates themselves. Let's test that assumption. We take the formula for capacitance, epsilon 0 times area over distance, and substitute it into our energy equation. Through algebraic simplification, we isolate the surface area and distance variables together, right alongside the electric field variable. This grouped term, area multiplied by distance, calculates the exact physical volume of the empty space between the plates. The math gives us the final answer to our spatial mystery. The stored energy does not actually live on the solid metal plates. It is stored uniformly throughout the empty void as energy density, residing entirely within the invisible electric field.